Now, the fourth problem on this exam, part B, is asking to find the equation of a plane. Now, it gives us a point that the plane is passing through, 1, negative 1, 1. And they say it also contains a line of intersection of these two planes, x plus y minus z equals 2, and 2x minus y plus 3z equals 1. So there's a lot of information here, but what we need to know is that the equation of a plane can be written as the vector ABC dotted with the vector x minus x naught, y minus y naught, z minus z naught. Alright? When you would solve this dot product out, it would then show that this line, which is going to be considered the normal line of the plane, would be multiplied each coefficient by x minus x naught, y minus y naught, z minus z naught. Now, first we need to find this normal, ABC. To do that, we would have to calculate the cross product of these two planes normals. Now, that may not make too much sense in words, but what we would do is find two vectors, A and B, such that their cross product is equal to the normal of this plane we're talking about, ABC. Now, first we need to find these vectors. Okay. What I would do first is find values where z and x are equal to 0 so that we can figure out points that lie on both of these planes, because we're trying to create a normal line or a normal vector that contains the intersection of these. So to satisfy both of these equations, an easy way to do that would be to set z and x equal to 0. Now, when z is equal to 0, this equation would become x plus y equals 2, and then the second equation would then be 2x minus y equals 1. To satisfy both of these equations, we would have that x is equal to 1, y is equal to 1 as well, and z is equal to 0, as we stated in the initial condition. Now, if you look at these equations, if you plug in 1 for each of these values, you'll have it satisfied. So 1 plus 1 equals 2, 2 times 1 minus 1 equals 1. So there we go. We have 1 point on both of these planes. Now, another point to find would be where x is equal to 0. Now, with that condition, we would have the first equation, y minus z equals 2, and negative y plus 3z equals 1. Now, to satisfy both of these equations, we would have to have x equal to 0, and then y would have to equal 7 halves, and z would have to equal 3 halves. Now, I just used arithmetic to solve and find these values, but if you plug them back into the equations, you'll see that they are both satisfied. Now, we have these points, and now we have to create vectors A and B from these points. All right, so we have this, and we have the point, a third point that is falling on the plane that we're finding an equation of. To find these vectors, we would simply take the original point given and subtract it from the other points we have to create on this plane. We have these 3 points, and we would create vectors A and B, and then by taking their cross product, we would create a third vector that is perpendicular to both A and B for a geometric representation of this. Alright, now to find that normal, we have to find these vectors. Alright, subtracting these points, you would get 1, negative 1, 1, minus 1, 1, 0, which would equal vector A. And that would be equal to 0, negative 1 minus 1 is negative 2. And 1. Vector B would be the same point 1, negative 1, 1, minus our second point, which would then be 7 halves, 0, 7 halves, 3 halves. And when you solve that, you would get 0. Oh, you would not get 0, you would get 1. I'm sorry about that. 1, negative 9 halves, negative 1 half. Alright. Now that we have these two vectors, we can find the normal vector. Normal vector is equal to the cross product of A and B, which would be 0, negative 2, 1, 1, negative 9 halves, negative 1 half, I, J, K. Okay. When we solve this determinant, we would find the normal vector equal to negative 7 halves, 1, 2. Now that we have the normal, we have A, B, and C, which we were talking about in this original equation. And we already have x naught, y naught, and z naught because they are the point, the initial point that they gave us that the plane is passing through. Okay. So now we can set up this equation of a plane. By the way, I forgot to say this earlier, but this entire equation is equal to 0. That satisfies the equation of a plane at a point x naught, y naught, z naught with normal A, B, C. So to find this equation, we plug in all the values, which would be n dot, well, it would be this. So n is equal to negative 7 halves, 1, 2, and we would dot that with the vector x minus x naught, which is, in this case, 1, y minus y naught, which is in this case is negative 1, so y plus 1, and then z minus z naught, so z minus 1. When we do this dot product, we get the equation negative 7 halves x minus 1 plus y plus 1 plus 2 times z minus 1 equals 0. Sorry about that. There we go. Alright, so what I did here is I plugged in the normal for each of these values, and then I plugged in x naught, y naught, and z naught. When we multiply this out and distribute and solve so that it is in a standard form, we would get that negative 6 equals negative 7x plus y plus 2z. And that is the equation of the plane that passes through the point 1, negative 1, 1, and contains the line of intersection of these two planes. That is your solution. Alright. And now we move on to question 5. Okay. Question 5 gives us an equation of acceleration and asks us to find the position vector and the velocity vector with respect to t. They're given two initial values, r naught and v naught,